All right. Hello, hello, hello. Today I'm just going to live stream using this repo that I recently created, which helps you get an Azure PostgreSQL flexible server deployed and then enable pgvector on it and use pgvector in some Python code. So yeah, let's just dig into that. Maybe I'll start with the end result so we can see the end results. Let's go to this one. All right. So here I'm going to run this bit of Python code. And we can see that it is authenticating to my PostgreSQL database using my Azure identity. So this is one of the things that I did as part of this repo. Let me switch. Let's see so you can see more detail. Here we go. Okay. So what you saw is that it authenticated using my Azure identity as opposed to using a traditional, password like long-term password. And then it looked up the 5 most similar movies to Winnie the Pooh, which is just a little vector database that I set up with these embeddings for these movie titles. And so we see some very similar movies for Winnie the Pooh. Okay, so that's the end result, as being able to do that. Let's see, let's build up to that. So this repo includes infrastructure as code. If you know me, you know that I love infrastructure as code, which you might know as Terraform. In Azure land, we use Bicep. You can also use Terraform, but I'm pretty used to Bicep, and it's Azure specific, so it tends to work pretty well. So I've got the, this Bicep here, and this Bicep, isn't making very much. It's mostly, we're really just making a resource group, and then it is making a PostgreSQL server inside the resource group. But there's some interesting stuff going on when we create that Postgres server. So I want to show a few things here. All right, so here is how we create a Postgres server. So we can see, the tier, and that affects like how much money we're going to pay on it and what sort of capacity we get. Then we have what sort of authentication we're using. So this is something that I actually changed. So I specifically disabled password auth and enabled Active Directory auth. So you can only authenticate to this password using an Active Directory user. And so that's, nicer from a security perspective. Then we have the version of Postgres 16, I think. Oh, it looks like that's as high as we go. I was thinking maybe we could go to 16, but the IntelliSense thinks it's up to 15. Then, our storage. Okay. So then in order to use this Active Directory authentication, we create this administrator, and we give it a name and principal type and a name here. So you can see the values of those. I think I set them in here. So you can see the type is user. This is going to be their, the object ID is going to be my principal ID. So that's a crucial thing, actually, is the object ID. So let's go back to looking at this. So that object ID, this is actually my own principal ID. Okay, so that is setting me as an administrator. So I can log in. So as long as I'm logged in, it can use a token from my account. Then I create a database. Then I set up some firewalls here. So this one is the allow all IPs. I did this one just so I could use this from my computer. You could also just whitelist your specific IP. So if I, did, what's my IP, then I could just do start IP as, my IP, and then end IP would also be my IP, and then you would be whitelisting a single IP. So that's generally better, is to, whitelist only the IPs that need access to it. The best is if no IPs need access, of course. The most secure thing is something that no one can reach it. But a lot of times you do want to be able to work with something locally. I also have the Azure firewall, which allows access from Azure services. And yeah, this is the option if you did want to do a single IP. I think right now I'm enabling, I just did the allow all IPs firewall. Okay, and then finally, this is the really exciting thing, and the thing that I've added recently is being able to enable pgvector. So to do that, we have to use this flexible servers configurations resource, and we have to name it Azure extensions, and it's a child of the server that we just made, and it has to have the properties value is vector. Vector is the name of the pgvector extension, not pgvector. And this is something that confused me quite a bit because I didn't realize, everybody says pgvector, pgvector, but in fact, the actual name of the extension is vector. That's the name of like the binary it produces. That's how you configure it. So this is what enables pgvector. So, enables pgvector. And this we use, this saying, this is how we're specifying it. All right. So that configures pgvector. So then if we look at what actually got made, here is the Postgres server that got made. We can see, the configuration, the same here. Now, we could also look to verify how the pgvector got set up. Well, you can check it. Basically, you can like check everything, right? So we could look to see, okay, what is our networking rule? So you can see that it does have the allow all IPs rule here. If that was, too permissive for you, you could change that to just your own IP address. You can also change it to be inside of VNet. We've got the databases, and includes the one that we specifically made, which is called DB. The rest of them are always default created. So it's always going to make an Azure Maintenance, Azure Sys, and Postgres. But you can also make additional databases if you like. Then we have, I wanted to show the authentication here. So here it says assign access to Microsoft Entra authentication only. And that's because we disabled password authentication. And you can actually see down here, this is the admin that I added. So, this is what I'm going to log in as. This is my principal ID, and the type is user. And then finally, let's look at the server parameters. And I'm showing you all this in the portal because also if you want to just do this in the portal, you can also set this all up in the portal. I just really like to do stuff with Bicep, but we can do everything in the portal. So if we look at Azure extensions, we'll just filter down to there. We can see that the value is vector. So this is a long list of all the extensions that you can enable on Azure Postgres Flexible Server. So it includes stuff like Post, GIS. It's actually really tricky to enable vector because it's the very, very last one in the list. And usually for me, it's cut off. That's the other reason why, I use Bicep is because this drop down is just so long that vector gets cut off. So if you are doing this in the portal, you have to trust and believe that vector is at the bottom of this list. And eventually you will find it there. Okay, so this server is all set up the way I wanted it. So if you wanted to set this up, you could just clone the repo, and then you can follow the README instructions to use AZD to set it up. So you run AZD provision, and then that would create that Postgres server. So now let's look at the code for connecting to it in Python. So I'll start with the simplest code, which is this psychopg. So psychopg is a driver, a package, I guess, with a driver for connecting to Postgres. A lot of ORMs build on top of psychopg. So maybe you haven't directly used psychopg, but you've probably used an ORM that has used psychopg if you've done any sort of Postgres in Python. So what we do here, so I load in my .env, and the .env has all the values based off of the provisioning steps. So it's got the database name, it's got the host, and it's got the username, and that's based off that Entra admin role that I made. And then it says SSL is required. That's a good thing to use when you're connecting to a Postgres server, is SSL. So these are all the environment variables it needs. And we could also use this example with just a local Postgres database that's set up in the dev container, and that's what the connection will look like there. But today we are focused on the Azure. All right, so then going back to PsychoPG. All right, so we load in our environment file. We get the host, we get the username, we get the database. The next step is where I try to figure out, should I be authenticating with my Azure credential or just authenticating, using a normal password to a local Postgres server. So I check to see if the host ends with database.azure.com. That's my signal that I am connecting to a production database, a deployed database. And so that's when I say, okay, I'm authenticating, use my Azure identity. And then I'm using the Python default Azure credential class. This is from the Azure identity package. So this comes from Azure-identity. And this we use in all sorts of all sorts of Python code. And so that default Azure credential class is actually pretty interesting because it tries to look for all different, lots of different forms of authentication, because there's many ways you could actually authenticate to Azure. So I typically use AZD because that's what I use for provisioning. So I do AZD auth login, but I could also do AZ login if I wanted, right? And it would work with all of those. So you can actually see all the different things it looks for, right? So if you're on Windows, it looks for things. It looks for Azure PowerShell login. So it tries to look for all the possible ways you could be logged into Azure. And once it finds something that succeeds, then it uses that. So I get that credential, and then I tell it to get a token for this resource here, from this authorization server. So this is the authorization, the token server for Azure databases. And it's a funny URL, database.windows.net. And we're not anywhere using Windows in this example, but that's just, what the URL is. So that's how we get the token. And then the token is an object that has a token property. So we set the password equal to token.token. And that's it. So this ends up being, I actually looked at this earlier just to see what it looks like. It ends up being this super, super, super long string. And, and it works as a valid password. And if we're local, then we can just use our boring local password because we don't care. But I really like being able to use tokens for deploying, for connecting to deployed servers. All right, and then we check to see if we need to enable SSL mode, and then we finally connect to the Postgres server. The next thing we want to do is actually start working with the pgvector extension. So here we have the call to create the extension. Now you might wonder about, why do we need this if we enable the extension? But it's two different steps. So we need to enable the extension on our Postgres server, but then we also need to issue this command to create the extension after we've connected to the server. So you don't have to do this every time. You should only have to do this once for, probably for database. But then, you have to do it at least once, and then you don't have to do it anymore. So however you want to put that code, make sure you do that at least once before you start using this extension. Then I drop table because I'm trying to make these examples be some things that can run over and over and over. Typically, you don't want to drop your tables, depending what they are. And then I create a table that it's a very simple table to start off with. This has an ID, and then it has an embedding column, which is a vector type, which is 3 dimensions long. That's what that 3 means. So we're only able to use this vector type because we've got this extension enabled, right? If we didn't enable the extension, we would get an error at this point. So we create this table here. And then the next step is creating an index. You don't have to create the index, but it's definitely best practice is to create an index so that you can get more efficient search when you have, actual databases that have many, many, many rows. So this is creating the index. This one's using HNSW, which is a popular indexing algorithm that stands for hierarchical navigable small world. There we go. It's a graph-based index. It's used to approximate nearest neighbor search, a popular method for similarity search in high-dimensional spaces. There's some great resources online on YouTube and GitHub that explain it more. So that is a very popular index. The other one is IVF, and I believe we can do both of those with pgvector. Let's just double check. This is the pgvector Python documentation. And yeah, we could also do IVF. So those are the two big ones, is HNSW and IVF. And we should be able to do either. Yeah, so they call it IVF flat. So that's what it would look like, is IVF flat if we wanted an IVF index. So you can look into that other option as well. Here we go. Also popular. All right, so then we insert the 3 vectors, and here's what's interesting is that we're using this pgvector Python package as well in order to support our use. So I think I've got to import it up here. Let's see. Actually, I didn't have to import it in this case, but generally they recommend using np.array as the way of storing these vectors. So that's from NumPy, right? So we're using the NumPy array format to store the vectors. So we say, okay, insert into items, and here's the values. And that inserts 3 rows. Then we can select all of them, but where it gets fun is to, start measuring how close things are. So you can do an order by, and here I'm ordering by how close is, a target embedding. This is my target embedding. How close is it to the other ones? Let's do a select with an order by. And this right here is a distance operator that you can only use on vector fields. Let's check what it is. It is I'm trying to remember if this is the cosine distance. I assume this must be the cosine distance because that's what I usually use. But there's both cosine distance and Euclidean distance. Let's look at pgvector proper, because pgvector proper is going to have them written out more. Here we go. So this is, so this one is L2 distance. But it also supports inner product distance and cosine distance. So cosine distance is actually the one with the equal sign. That's the one we want to use when we're doing OpenAI embedding comparisons. So yeah, we've got 3 different special distance operators that are only enabled when we use this pgvector extension. All right, so here we get the closest ones. We can also calculate the distance, and with some SQL, calculate the average, find vectors within a certain distance. So these are all just distance related calculations. It's very similar to kind of things we could do with PostGIS with latitude longitude coordinates, but here we're in vector space, in similarity space. We're trying to figure out for this vector, what's the closest items to it. So let's go and we can run that. And if any of you have questions at any point, please stick them in the chat. All right, so that's our starting example. Now we'll get a little fancier. Actually, let's see if we can view it in our Oh, okay, it wants the password. Okay, so the one tricky thing with using this this kind of passwordless authentication is it does make it harder to use SQL tools. You can still totally use SQL tools. So SQL tools is this extension right here for browsing databases. So I can show you what the local database looks like because I already had it. I should already have it set up. Yeah, so we can look at the one I made, right? So SQL tools is super cool. Oh, I must have dropped that one. Let's see if it's, do we have it any? There we go. So here's like all the movies, right? And so you can see them with their vectors. So it's a lovely VS Code extension for browsing your databases locally. And you can set it up to connect to your local database. You can also set it up to connect to a production database, but it's going to need your password. So the way I did that earlier was that I actually printed out that token and then I pasted it in when it asked for the password because I didn't want it to store the password. So it is possible to connect with SQL tools, but you do have to get that token and then paste it in when it prompts for the password. So I'm not going to show it because then you're going to see the token. But totally really cool extension. I recommend trying it out because it is a fun way to be able to browse your tables locally, and you can even run raw SQL queries in it too. All right, so yeah, so this movies table here, this is based off, let me show you the JSON I have. So I've got this JSON here. Oh, and it doesn't want to open it because it's so big. Oh, well. Yeah, that's the thing about vectors is they're very big. They take up a lot of space. So this is a JSON file that has movie titles and then embeddings, and the embeddings are purely of the title, and it's using the OpenAI text embedding ADA002 model. Now there's new text embedding models that can be smaller, right? So this one is 1536 dimensions, which means 1536 floating point numbers in order to, store this embedding. But if we were going to use one of the new models, we could go as low as 256, and it would probably make a lot of sense, especially given how how small of a thing we're embedding here. I imagine that using 256 would work just as well quality wise. But that's where the data came from. So I already had it. I already had the embeddings computed for that one. So let's look on how we could use that movies data. And here I'm using SQLAlchemy. So SQLAlchemy is my favorite ORM for Python. Shout out in the chat if you like SQLAlchemy. And it's probably the most popular ORM. And it's great because you can use it with lots of different databases, lots of relational databases, SQL databases, different drivers, and you can also use it async. And that's something I've started to use more. So I do also have an async example here, so that if you're using this inside an actual application, you probably do want to use async just for better concurrency in your application. But we can just look through this simpler example here. So we define our movie class, and we say, okay, it's going to have an ID, it's going to have a title, and it's going to have a title vector. And this is a vector of 1536 dimensions. Now, where did this vector class come from? Let's go up here. So that actually came from the pgvector Python package. So here we have to use both SQLAlchemy and the pgvector Python package. And the cool thing about the pgvector Python package is that the maintainer has gone through effort to support all of the popular, SQL database packages, right? So this is really covering a huge swath of what people use. So very well done on that maintainer. All right, so we create that, that column there, which is a vector. Then we create the index. So this, this is index is a class from SQLAlchemy. We give it a name. We say which column we're making it on. We tell it, this is all the special stuff that it needs that are specific to Postgres. So we say, okay, you're using HNSW. These are the parameters. So these are specific to HNSW. There's some great videos on YouTube from I think on the Pinecone channel or the Pinecone creator, where he he compared different M and F construction values. So these will affect how the index gets set up and how much space it uses, how much time it takes. So you can start with the defaults, but if you're interested, you can, get into more details and you can configure these. And then we're telling it which operation to use, right? Because we had L2 distance, the inner product, and cosine. So we're telling it to use cosine. And we're using cosine because we did embed these using Ada002. So if you are doing embeddings with Ada002 or the new OpenAI models, you should be doing cosine distance and not the other distance operations. Okay, and then we have the same, pretty much the same authentication dance as before, right? Getting our token if we're connecting to the prod database. So we create an engine based off that URL, that database URL. We create the vector extension if it doesn't exist. We create the tables and indexes. And then we begin a session where we can insert data and query data. So this is where we insert all the movies based off that JSON file. So we're just doing a bunch of ads and then committing it. And then we can start querying. So let's see if anyone has any movies they want to see similarity for. Disney movies, has to be Disney movies. Please put that in the chat. So here we're finding the movie where the title is Winnie the Pooh, and we are, erring if we don't get that. And then we're trying to find the 5 most similar movies to Winnie the Pooh. So we say, okay, order by the distance to this movie and give us the 5 closest ones. And then we'll print them out. So let's go ahead and run that one again and look to see what else we could check. So Aristocats, that's actually one we like to watch a lot in our house. Maybe we'll do that. Similar items for things that are existing in here, because what I need an embedding. Now, if I wanted to be able to match to just arbitrary things that a user put in, then I would need to bring in an embedding model, bring in like the OpenAI embedding model and the OpenAI SDK, and I'd actually have to, turn a user query into a vector using that embedding model, which you can totally do. And I'm working on another sample that does that. This one only works with existing vectors, which is still useful because if you have like a product catalog or something like that, you have any sort of things in your database or kind of public things, you could compute embeddings for them and then immediately have this similar items functionality. Now there's many ways to think about what makes something similar, especially like products. It's usually like that one user, a user that buys X also buys Y. So this isn't necessarily the right similarity algorithm for all the jobs, but it's kind of an interesting similarity algorithm to be able to throw into something fairly easily. All right, so let's try it with the Aristocats. Oh, okay, we've got some suggestions. Okay, hotel. All right, so first up is going to be Hotel Transylvania. Is that actually, did you see it in the list? Is it on here somewhere? I never even heard of that. Let's see. Well, we'll find out, won't we? All right, so for Aristocats, we got a bunch of cats, mouse, and a fox, of course. Okay. All right, I feel like Up is definitely going to be in the list. So actually, all right, we'll try Hotel Transylvania, but I've never even heard of that one. I don't even know if I'm going to spell it correctly. Is that really a Disney movie? Let's find out. Hotel. Oh, it's 2012. And I think I spelled it right. Okay. All right. My data might be too old for that. Let's find out. We might just get an error not found. For a 4-year-old, or is it totally cool? And this 4-year-old definitely knows vampires because we read Vampirina all the time, which is like a little, 8-year-old vampire. All right. So unfortunately, our data is out of date and doesn't have Hotel Transylvania. Let's try Up. Up is from a lot earlier, I think. What was it, like 2011 or something? Okay. Do we have Up? Or is this just going to be like super old? Let's see. Let's go next. Might have to go to like 80s Disney movies. 3 Men and a Baby. Oh, there we go. Okay. So for Up, we got Step Up, Alive, The Air Up There, and Splash. So that's really interesting. So remember that these embeddings were based purely on the title. So for an embedding for just the word up, it's so connected with like the meaning of the word up that everything it came back was like just very connected to the word up versus Winnie the Pooh. Like Winnie the Pooh semantically is, is like a movie, right? So if you actually wanted to implement like similar items for movies, a better thing to do would be to have the movie title and the movie description, like a paragraph, and concatenate those together and then make an embedding based off of both the title and the description, because then you'd actually get things that didn't just happen to be similar to this very short title up, and we're instead actually similar to the idea of a movie called Up that has this description, right? So like anything you think that is semantically relevant, you would want to create an embedding for, and you could stuff it all into the same text field and make a single embedding based off of everything you stuff, and you don't even have to like store the text. You could just store the embedding. But right, because you could have title, you could have genre, you could have age range, right? All those things could be relevant for the embedding, and then you could have a single embedding file, and then you would get much more accurate response for Up, because Up should really be giving back like similar, like kids movies, animated, that sort of thing, travel, etc. All right, so let's see. So next, let's see. Okay, question. Is if I have a recommendation system where people search for things and we recommend the most similar things from the database, is it worth transforming my entire database to vectors and applying search based on it? Will it be faster? Or if it's not worth it and the keyword search will do the same? Logically, it might be faster if we're comparing numbers instead of strings together. Yeah. Okay. Great question. So, so we're basically we're talking about vector search versus keyword search. And you're actually thinking about, it looks like you're thinking about actually the performance of it. So that's a good question as to what is the actual time taken by these queries. Let me make a note for that. Investigate time taken, because I'm working on another repo that does a hybrid search. So it does both a text search and a vector search. And I could profile that and see what it's like. So, for vector versus keyword. Now, when you say keyword, my assumption is that you're doing full text search in Postgres, because Postgres has this TS full text. Here we go, controlling text search. Okay, so it has this all these functionality here in order to do full text searching. Yeah, and John says he is doing that. Yeah. Okay, great. So you're using this. All right. So if you're using this, I still think it's that vector search can yield you things that full text is not going to yield, right? Like if we think about why we use it for RAG all the time. If we look at the RAG relevance, blog post, which is my favorite blog post, but it has this great, where's the query at the end? Oh, I wanted to find, no, there was another one I wanted to look for, which is the query types, right? There was one, let's see, maybe it's in here. My decks. Okay, this is what I wanted to find. Okay, and we go, whoa, 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 whoa. Okay, this is what I wanted, right? So impact of query types on relevance, right? So, obviously for some things, keyword search is very good, doing a keyword query, or exact snippet search. And vector will do, very poorly on that. But then there's some things where vector will do much better, right? So you see here, they call it, concept seeking queries, right? So if you're looking for like for movie search, right? If I'm looking for a movie about transcending mortality, right? Transcending mortality. There's no Disney movie called Transcending Mortality, but that is a concept that can be semantically encoded, and then I can look for it, right? And that sort of thing is that when we embed stuff in a similarity space, we're embedding their concepts as well. So if somebody clicks on, Spirited Away, is an animated movie, and you think about it being a movie for kids, but it's also incredibly popular with adults, and because it has all these, all these kind of deep themes, right? And so I think that a vector search is going to yield some potentially more interesting similarities, similar items, than a keyword search alone. Oh, you can't see me. Sorry. I should put myself at the top. Yeah. So I think I definitely, I'm a big believer in hybrid search, and that's why I'm trying to, use it when possible. There's actually some examples in the pgvector Python on hybrid search with a couple different ways of doing it, right? So here's one hybrid search example. And this one uses the TS vector, right? So here's a semantic search. And these are just doing raw SQL queries, right? So there's the vector search using the cosine distance. Here's the keyword search using the TS vector. And then, so what this example does is that, it uses async IO to do both the semantic search and the keyword search at the same time. And then it runs this re-rank step. And for the re-rank step, what they use is a model. And this model tries to, figure out what's the optimal ranking of these results based off the original query. And so you can actually run these. So the thing you'd want to check to see, how long does this take? How long does this take? How long does this take? And is it worth it? Are you getting better results? And there's another way of doing hybrid search, which is using reciprocal rank fusion. And this is a very long SQL query. But this one does not involve a model. Instead, it just involves coming up with ranks for each of them independently, right? So it's saying, okay, here's the rank for this one. Here's the rank for this one. This is how it's going to come up with the rank. And then it attempts to kind of weight the ranks together in order to come up with their final rank. So that's another way of doing hybrid search. So both of these are, search versus similarity, but we should be able to use the same concepts. Yeah, so John was asking, how about performance-wise? Does it make the database super fast? So, I mean, generally using the index is going to help quite a bit. And so if you do find that your vector queries are slow, then you could look into different values for the M and the F construction, and that can help with index speed, but it could affect quality, right? So that's always going to be your trade-off, right? Is index speed versus quality of results. But I would first just do the profiling to see what the speeds are like. So I mean, we could do some here. Let's see, from I can't import time it. I do remember where these things are stored. Import time. I think it's time.time it. Let's see. And let's see. Time it using time it. Start time. I don't think that's using time it, but okay. End time. Oh, because time it is a command line thing. That's right. All right. So there we go. Time taken. All right. So let's try that out. Yeah, I was thinking that there's this time it module that you can use on the command line if you want to run a script a bunch of times, and it'll run it all those times and then do the averages and stuff. But here we can just start with this. We could also use scaling is really cool for like profiling. But here we can just run something a bunch of times. All right, so time taken 0.18 seconds. That was the time, from when I started this query to when I ended it. The actual time spent on the server is probably less, right? So we could connect to, if we connected to local instead, right? Let's see if we do, I'll just swap out my connection details here. So now we're connecting locally. And let's see how fast things are locally. 0.01 seconds, right? So locally, we saw 0.01. For the production one, we saw 0.18. And keep in mind, this example here, I'm going from my machine to an Azure server. If I was running this from like an Azure app service or container app to an Azure server, you can imagine that this could be a lot shorter because it would be, you know, quicker, much quicker distance, especially if they're all in the same, you know, in the same region, in the same resource group and region and availability zone and all that stuff. So I don't know how much of that is actually being spent on the Postgres server versus that network trip. So yeah, that's a good thing to look into as well. And then Yasir asked, can we use explain on vector queries? Great question. I actually don't use explain a lot, but let me at least turn on echo. If you tell me how you normally use explain, I can look into how to use it here. I'll turn on echo, which is what I do sometimes. And echo shows us the exact queries that are made. You know, to the SQL query, right? So explain, I think, is the, you know, showing like the query plan probably, but here we can see, you know, select, you know, so this is showing us what the SQLAlchemy code, you know, what SQL it turned into. Let's see how to use explain in SQLAlchemy. So this is always a nice thing to do in SQLAlchemy. I actually almost always have echo equals true on. I don't know why I turned it off. Maybe, yeah, just to simplify things because I'm doing all the print. Okay, so let's see, explain. All right, so it says you could just do explain. Okay, so let's just try in, maybe we should just try that in here in the psychopg and do explain. So you just put explain in front. Let's see. Let's see. Yeah, item on a range. Okay. And item. Oh, okay. I'm just going to print out the item because this is a different thing now. Okay. Oh, cool. Neat. All right. So let's see. It says seek scan, I guess sequential scan on items, cost, rows, width, filter, embedding. Okay, double precision. Okay, so this is what we got from the explain. I don't know if that helps in terms of how to reason about, you know, the time taken and the performance, but it does. It looks like we can. So I think the answer is that we can use explain on, you know, on these queries. So if that helps you, that's great. I obviously still need to learn more about how to use explain well. Yeah, great question. What else do I need to learn about? Any other questions? I can also preview the other one I'm working on. You know, which hopefully I'm hoping to show at the VS Code. It's VS Code Day coming up. So RAG on Postgres. So this is going to be a RAG on Postgres, like it sounds like. And this is where I'm going to try out those various ways of doing hybrid search. So here's my Postgres searcher class, right? So you see all my to-dos. This is a private repo right now. But yeah, I'm going to do the vector search and the hybrid search and, you know, do some re-ranking in there. And the hope is that we can also add on additional filters based off of what the user asked for by using an LLM to turn it into where clauses. So we'll see how that works, but I can show you the actual RAG flow. You know, is going to do searcher dot. Okay, right. So we get back, you know, we get back text, the user's question. We turn that into a vector. We use that to do a hybrid search. And then we give that to our GPT model and it answers the question. So we can in theory use Postgres in a similar way that we could use Azure AI Search, but it's a lot more work because we have to implement all the nice features that Azure AI Search has. So it may not make sense to do that when we have this great Azure AI search engine, but we're trying to experiment with it to see if we can dynamically build up additional queries here as well. And so that it could be a good resource for somebody who's trying to do RAG on an existing database without having to move it over and just add on a column. Oh, John asks, where is the cool output in the terminals? That's a completely different repo, but I have it open because I always have things open. So that is over here. Let's see, evaluate. Let's see, okay. So let's do blah, num questions equals 2. Actually, I should just have it in my history here. Okay. Let's see how it looks. So this is in the AI RAG chat evaluator repo. So this is my repo that evaluates RAG chats, and it's very, very script heavy, which means the scripts do a lot of printing, and well, they use logging to do it, but so they're logging out a bunch, and I was sad with how kind of boring the logs looked. So I added the rich handler. Oh, so you can even see it up here. I've got it in my history here, right? So, here's what it looks like with using. Let me find one before I added the rich handler. Let's see. Oh, I was messing with a lot of stuff yesterday. Boop. Yeah, I can't even find the before. Oh, but here's the after. Okay, now it's running. So this is with the rich handler. I'll show you the rich handler in here. Okay, so this is from Python rich package. You import the rich handler. And so then you, when you do your logging.basic config, you specify what handler that you want to use this rich handler. And then it just makes it really nice. It adds colors. It adds this really nice tabbing, so you can like really read it a lot better than before. It makes these things linkable, right? So you can see all the file names are now linkable and they're highlighted. Like that's really nice too. It auto colors strings. This stuff doesn't get done because these is actually logs within logs from like a sub process. So those don't get highlighted. But then when we're back into my script, then we have the nice results. So yeah, so I really liked the rich handler. So if you're doing anything in Python where you have a bunch of logging and it's like a command line script where you're going to see all that log output, definitely look into using the rich handler because it's going to make everything really, really pretty. All right. Cool. Okay. Well, that is all I wanted to show today. But if you want to try it out, this repo is Azure-Postgres-pgvector Python. I'll have a blog post about it tomorrow or something. But you can get started with it now. So please do try it out and file issues if you run into anything. This is my my first Azure pgvector repo, but I want to do additional examples, showing how to use this from an actual deployed app. Because if you are going to use this with a deployed app, you actually need more than just the Entra authentication. You actually have to create a service principal and then a managed identity. You do this managed identity with the service principal. So it's a little more complicated. So I want to show how to do that in an upcoming sample. All right. Well, thank you, everyone. I'll see you next time, whenever that is. Bye.